Then come back to here. You wrote the first page. Thank you, Sharma. Then you try to put your screen on, that photo in the group. Okay, right. Example here, the second one, what I am trying to say, suppose in a progressive wave, two points are selected at the times, sorry, not 2 points, in a progressive at 2 different times, a particle maintains a phase difference of 2 pi by 3. Okay, find the time difference. Find the time difference. Okay, here what do you want extra? The angular frequency is equals to, he said, like pi radian per second. Now you try to understand what he gave here, Nana. Angular frequency means what? Who is this angular frequency? Is it nu or omega or the time period? Who is this angular frequency? Anyone respond, please? Omega, right? Very good, very good. So angular frequency is omega, right? So omega, given that omega is equals to pi radian per second. Yeah, good. And the phase difference is given as 2 pi by 3. Okay. Then find the time difference between the is it 2 by 3, Nana? Sure. Or 1 by 3? Acha, MS. Okay, we'll check it. Actually, we have delta phi is equals to 2 pi by t into delta t. This is our formula. 2 pi by t is nothing but omega. I think all of you know it. So omega into delta t. Now once you check the answer, yeah, then here you will get the answer. Delta phi is 2 pi by 3 is equals to omega, right, pi by 2 by 3, correct only now. Omega into delta t. That implies delta t is equals to, after cancelling pi and pi, you will get 2 by 3 seconds. Exactly. So your answer is correct. Aditya and Shrestha. Right, good. Okay, understood that's problem, Nana, and the previous problem? Understood? Very good. Now, yes. Very good. Now we are moving to here. How to find the velocity of transverse wave. Okay. Velocity of a transverse wave. Okay. So velocity of transverse wave means irrespective of the nature of wave, that is like a transverse or longitudinal. For any wave, we can write V is equals to nu lambda. This is a common formula, leave it. Okay. For any wave, you can use this formula. Even though it is electromagnetic wave, we can write V is equals to nu lambda. This is wave equation. V is equals to nu lambda. Okay. To find out the velocity. But if it is particularly a transverse wave, okay, then how to calculate that velocity of transverse wave? When you come to objective, they ask in a stretched string. Okay, stretched string is best example to understand, like the string connected in the piano or the violin, there in guitar, there they fix one string to vibrate that string. Okay, that is called as stretched string. I think you understood, all of you. Okay, in the musical instruments, in guitar or piano. Got the idea, Nana? This is for both, Nana, Sharma. Yes, yes. This concept is there for both mains, advanced, and IP, for all types. Okay. This is there in IP 8 marks question also for board exams. Okay, long answer question. So try to focus on it, velocity, and then how to get the frequencies in the stretched string, all those things complete all together. It is 8 marks question, right? But the derivation actually not there in syllabus. If you are interested, I will explain, or else directly I will give the formula. Which one you want? You want the derivation or only the formula? Interested? Okay, no problem. Explanation, sir. Okay, right, Nana, Isha. Okay, Sharma. Then look at here. Suppose this is a stretched string. What I am taking, like the piano wire or guitar wire, here between 2 points, stretched, and here it is like a plugged, means vibrated, perpendicular to the stretched string, so that it tries to vibrate up and down. Up and okay, up and down means this is a transverse wave. When the transverse wave is moving in the stretched string like this, at an instant, suppose the string is appeared like this at a position. Okay, means while vibrating an up and down, at an instant I took the shape like this. Do you have any objection, Nana? Shall I take like this? While vibrating the wave up and down like this. Okay, right, good. So I am taking, this is the wave at an instant. Okay, at an instant, the wave, okay, good. The wave is propagated through the string, that too at one particular place, at a place as shown with the dotted lines. As shown in the figure. Okay, these dotted lines is the shape of the string at an instant. Okay, look at the wave is propagating like suppose produced here propagates towards right now. So towards right, suppose wave is moving like this. Okay, with a certain velocity. Okay, where v is the velocity of wave. Of the transverse wave. Okay, think wisely, Nana. It is appear like a part of circle at that instant. Okay, part of circle means in circular motion. To complete the circle here, the two forces must get balanced. One is by virtue of velocity, centrifugal force. Another one, centripetal force. Am I right? Centrifugal, if I ask you, again my voice is breaking, Nana. Or else is it clear? Today what happened, I don't know. In the middle we are getting some disturbance. Yeah. In between some breaking of voices. Now, Nana, now it is clear. Is it clear now? Yes. Okay, right. Now once again, you see here, it is not clear. Clear. Okay, right. Here, by virtue of velocity, you will get some centrifugal force, that is mv square by r, radius of curvature. Okay, m. Mass means where you are calculating, at that point you select one part of the string, stretched part, like this. This is the part what I selected. Okay, this part mass, who knows? I don't know. Mass of total string I know, but mass of that part I don't know. Let it be some dm. So on that small element, at this instant, the centrifugal force is mv square by r. Mass I consider as dm. So you understood this point, Nana, first? Is it clear? Okay, I will try, Nana. Sharma. Next time I will try. Okay. Clear, sir. Understood. Okay, right. Now that small part I am redrawing here. Okay. This is the small part I selected here. Okay. Small one of length, small length dl, of mass dm. And you said here centrifugal force on this is mv square by r, like this. mv square by r. R means radius, Nana. Radius I have to take like this, towards the center. Okay. So look at, this is the center, and it is the radius of that circular part I showed. Where here, this circular part what I showed. Okay. Little bit big one I drew here. Okay, to understand. Okay, and here suppose if it makes an angle 2 theta at the center, means half angle is theta, Nana. This half angle is theta. So total angle 2 theta. Using the sector principle, shall I write here angle is equals to arc by radius, or else L is equals to arc theta formula? Using that formula, theta is equals to L by R, Nana. Okay, theta at the center is yes, 2 theta, and length is dl by r using this formula. Sector principle. Okay, very good. So take it as first equation. Okay, then you may get some doubt. Sir, centrifugal force by virtue of velocity of transverse way you wrote here on the small element, that is dmv square by r, mv square by r. Why you require 2 theta is equals to dl by r? What is the use? Okay, for that, yeah, wait, you will get the answer for your doubt. Total length is dear Nana Sharma. Total angle is 2 theta. Okay, so total angle of the sector 2 theta angle is equals to, that is total angle 2 theta. Arc, length of arc is dl by r, radius. So now you understood, or do you have any doubt, Mr. Sharma? Yes, very good, very good. Right, then come to here. Nana, it is a stretched string. Stretched means tightly fixed at the two ends. Tightly fixed means while vibrating, pakka there will be some tension. Tension tangentially, tension tangentially at the two ends it will act. Okay, this is the tension T, it is the tension T. Okay, and here that tension, look at, if I take a horizontal like this here or there like this, and the vertical also like this. Okay, look at, if this angle is theta, then it is also theta, then tangent radius. Half angle is theta, Nana, correct only. Half angle is equal to half arc by radius, means half get cancelled, na. Understood? Right. Okay. Then here it is theta. Tangent and radius are perpendicular, so it will be 90 minus theta. If it is 90 minus theta, these two are perpendicular, so this angle will be theta. So is it clear, Nana? Angles, how we took? Very good, very good. Clear. So shall I erase these angles which are not required here? Okay, good. Right, I erased, and these are the two line cycles. Then resolve T into two components, Nana, here and there also. This will be T cos theta. Here also it will be T cos theta, and it will be T sin theta, and here it will be T sin theta. Okay, look at, for the small element T cos theta at the two ends in opposite direction. So shall I cancel them, Nana, on the element? Okay, yes, but look at T sin theta, both are downwards exactly in opposite direction to 2m, centrifugal force. So here for the small element, to balance the forces, shall I write T sin theta downwards and one more T sin theta downwards total downward force is equals to upward force dm into v square by r. Any confusion there for you? Yes, there is no confusion. Okay, very good. Then look at here, you will get 2 sine theta is equals to dm into v square by r. Okay, since the element I selected here, it is a small one, it is a small element. Okay, that small element makes a small angle at the center. Okay, small angle means, yeah, you have to understand that here the angle at the center, which is 2 theta, is small. Okay, at the center. 2 theta is small means obviously theta is small. If theta is small, sine theta can be written as how? You say, if theta is small, sine theta can be written as, already you know in your oscillations chapter. Oh, babu. Not cos 180 minus theta. Theta is, sine theta is nothing but theta. Yeah. That you know in the derivation of the time period of simple pendulum in oscillations chapter. Sine theta there also you took as theta. Okay, good, good, good. So sine theta is theta. So I write it as 2t into theta equals to dm by r, dm into v square by r. So any confusion in this step? Any confusion on here? No. Very good. No confusion. Very good. Now look at, I write it like t into 2 theta equals to dm into v square by r. Now check back the first equation. What you got here? First equation, 2 theta is equals to dl by r. No? Okay. Now from the two equations, solve the two equations. That implies from 1 and 2, I write replace means substitute 2 theta equals to dl by r here is equals to dm into v square by r. Okay, then r cancel. That implies t is equals to, I will get dm by dl into v square. Okay, it is appeared like mass per unit length. Okay, where dm by dl is taken as mass per unit length, which is defined as linear mass density. Okay, so dm by dl, I take it as linear mass density represented with the letter either lambda or mu. Any letter you can take. Better we avoid lambda. Why? Because in this chapter, lambda already we represented the wavelength. That's why to avoid the confusion, I go with mu, Nana. Do you have any objection? Till now with mu, no physical quantity is there in this chapter particularly. Okay, so shall we go with mu instead of lambda? Yes, right. So I'm going with mu, Nana. That implies here. Okay, thank you. That implies here I write t is equals to mu into v square. Now you are getting the formula for velocity. V square equals to t by mu. Therefore, velocity of transverse wave v equals to, you got the equation, root of t by mu. This is the formula. Okay, restricted only for the transverse wave, not for all mechanical waves, only for transverse wave, that too in a stretched string. That you should not forget. In a stretched string, conditions applied. Okay, only in a stretched string, that too transverse wave travels with a speed of v is equals to root of t by mu. Okay, if mass is not variable, if mass is variable, Nana, then you write like this. If mass is variable in the string, then I write mu is equals to dm by dl. If mass is variable, anywhere we have to go to integration part, Nana. For variables, we go to integration. Right from the first year, we did the same. There to substitute in place of dm, I write mu into dl. Okay, this is one formula if mass is variable. Number two, if mass is not variable, mass is constant, not varying. Okay, mass is better, I write not varying with the distance, with the length. Okay, then I write mu is equals to directly m by total mass by total length. Keep in mind. Okay. Now you understood both the points, Nana? Any doubt here? From velocity of transverse wave, from their linear mass density. Understood? Okay, very good, very good. Okay, that's nice. Once again, I am repeating, it is at the velocity of only transverse wave, that too only in a stretched string. Okay, don't apply this formula in all cases. So before applying the formula, read the question properly. Conditions applied. What are the two conditions? In the problem, he has to mention a string is stretched. And number two, find the velocity of transverse wave, not longitudinal wave, only transverse wave. Then v is equals to root of t by mu. There, suppose mass is not varying with the distance, then mu is equals to m by l. Okay, if it is a variable, dm is equals to mu into dl. Yes, Manikanta, do you have any doubt in this page? No, very good. Okay, right. Then come back to here. Okay, after finding out points to remember, what are the points we have to remember before going to encounter the problems? Okay, so points to remember related to this transverse wave. What is this? Okay, number one, velocity v is equals to root of t by mu, where mu is equals to total mass by total length, or if it is variable, dm by dl. Okay, better I write here the linear mass density is constant to avoid the confusion. If the linear mass density is constant, mu is equals to m by l. Here also I write if I write the linear mass density is variable, then I write. These are the two equations. Okay. And here, this is sure, Nana. Okay. Obviously. And next, the second point that you have to expand means try to, while to solve the numericals, try to write the same formula in different ways. What are the different ways, sir? First, check that linear mass density mu is equals to in the above step, you wrote mu is equals to total mass by total length. Na? Total mass, shall I write it as density into volume by length? And here, yes, the volume, shall I write it as area into length divided by length? Okay. Why you wrote, sir? I think now you understood. Length get cancelled. That implies, shall I write mu is equals to rho into A, that is A rho. Is it correct? Okay. Now you can say if linear mass density is constant, it is independent of length. Length term is not there, keep in mind. Okay, we got rho into A. That is mu is equal to m by L when we write. If mu is constant, I clearly mentioned here. So that is if mu is a constant, linear mass density is a constant, then I can write then the linear mass density is dependent or independent of length? Independent. Am I right? Independent of length. Yes. Then it depends on whom, sir. It is independent of length. Correct. Depends on whom. One, density. Density means gives nature of material. For different materials, rho is constant. So nature of material for silver wire, gold wire, platinum wire, iron wire, zinc wire, like for different wires, rho is different. And number two, keep in mind, it is depending upon the area of cross section. Okay. And I write here, it depends on nature of material, that is rho, and the area of cross section, cross sectional area, capital A. Okay. Usually the wire's cross section is circular. Okay, that's why if you want to write area of cross section as pi r square, you can substitute here as pi r square depending upon the problem. Okay, and this is one formula. And the tension you can write from the mechanical properties of matter. Okay, not thermal properties, mechanical properties. So third point here I write, for a given wire. Okay, shall I write given wire means whose length is more, area of cross section is less. Lengthwise modulus is Young's modulus, Nana. Why? Which is Young's modulus? Able to recollect, Nana? This is actually formula F L by A E. FL by AE, where F is restoring force. That restoring force in the stretched string is tension. Okay, tension is the restoring force in the stretched string. So shall I write here in place of F, the restoring force, T here? Okay, is it correct? TL by AE. Right. So look at Y into E by L. If I take L and E to the other hand, you are exactly getting T by A. Okay, what is the use of this formula, sir? Then go back to the velocity formula. Root of T by mu na. In the second point, we got mu is A into rho na. Here in the second point, A into rho na. Then here look at T by A term we got. So T by A, why don't I replace with root of Y E by L into, in the denominator, rho is there. Okay, this is one more formula here. Okay, right? And last but not least, once you check over there, Nana, this is one formula what you have to remember. This is the another formula, and this is one more here what we derived. Mu is equals to rho into A, and this is theoretical, very important point when you come to advance. Okay, it is independent of and dependent of whom, very important. And then one more here, V is equals to YE by rho L. Okay, and last but not least, about to stop, Nana, don't worry. Okay, there for 1 or 2 minutes. Just here I'm going to write V is equals to root of Y by rho into this E by L. Try to recollect. E by L, delta L by L is nothing but the strain in the same chapter, mechanical properties of matter. So shall I write over here Y by rho? Right, that is strain, longitudinal strain. So shall I write here simply strain? So Y into strain divided by rho. This is one more formula for the velocity of transverse wave. Okay, Nana? So these are the different forms of velocity of transverse wave. Thank you, Sharma. Velocity of transverse waves, different forms. Okay, so I'm going to stop the class here, Nana. If you want the pages, you can take the pages. Do you want the pages? Yes, okay. Come to here. What happened? Yeah, come to here. Where is my mouse? Here. This is the first one.